Hello everyone. In this lab, we will be learning how to establish a certificate authority, issue a digital certificate to a company, set up an HTTPS server using this certificate. So the lab environment would consist of an Ubuntu system and a Kali VM. Ubuntu system, Ubuntu system acts as a certificate authority, and Kali VM would act as a client, and it is also used to test the configurations. Before we start off with the tasks, make sure you have the following packages installed in both your Ubuntu system and as well as your Kali VM. So libSSL, OpenSSH server, and OpenSSH client needs to be installed in both the VM and your Kali. Check for the current version of the OpenSSL library which you have by using this command. And so most likely you would want to install libSSL 0.9. So how you do that is so it starts off, since it's in the newest version, you do not have to. I've already installed in this, so after this we have to install a set of other packages. So now we set up the OpenSSL package, and then we also install the OpenSSH server. If it's already installed, it is not. It just shows that it's already installed. Once this is done, now we install the client. So the client has already been installed. Now the first task is about learning of the OpenSSL basics. First thing we need to do is find the version of OpenSSL, and then find the additional information of OpenSSL encode subcommand, and then it would be to find out all the available encryption algorithms or the cipher algorithms, and then to benchmark the computer speeds with OpenSSL for each encryption algorithm, which makes use of OpenSSL speed. So I have created a shell script for it, and now when we run it, so it shows that. So yeah, so coming back to this, now when we run the shell script, we can see all the four tasks in this subtasks in this task. So first one is how to open the SSL version, and then these are the encoding algorithms. OpenSSL version is this, and then this is the various encodings, and then coming down we will have all the ciphers. And then we will have the speed for each of the algorithms, which sets up the benchmark for the computer's speed with the OpenSSL. Task 2 is setting up of certificate authority. What we need to do first is to create a directory called lab02, and then what we do is copy the OpenSSL.config file from etc/ssl to your directory so that you could make changes. And after that, what we do is we also create necessary files, that is the index.txt and serial files. So let's just execute this. So yeah, now the OpenSSL has been copied. So now let's just enter this path and check for the OpenSSL. The main things that we look into in the OpenSSL file are in the CA underscore default, you create a directory called demo CA, and then we also create the index.txt and the certs and new certs. So now the command that generates a self-assigned certificate for the root is this. So when we run this, it will be prompted for a key phrase. So just give in a key phrase. It will also ask for a set of other information. So make sure you enter all the other informations. So once all the information such as country name, locality name, everything is entered, this will create a ca.key file. So when we see this, this is nothing but the encrypted private key which is created for the CA. So you will also see a ca.crt file, which is nothing but a certificate which is created for your CA. So this completes task 2. Task 3 is about issuing of certificates to clients. So the first step would be to generate public or private key pair for the client using this command OpenSSL gen RSA DESSD algorithm, which we'll be using, and it will be outputted to server.key. We will be prompted to enter a passphrase for server.key, which we can use to access the server.key next time. So the next task would be to generate a certificate signing request for the client, which is using the server.key, and it will be outputted to server.csr file. Here we need to enter the passphrase which we had given previously. Make sure you give the same country name and the state province or province name as you had given for the certificate authority, otherwise you will be prompted to enter the same. And then also give your common name as what you like, because in task 4 this will help you. And then you'll be prompted for a challenge password and an optional company which you can enter or you can ignore. Now the next step is to issue the certificate. So issuing of a certificate would be the ca.crt is a certificate of the server of the CA authority, and then your output certificate will be stored in server.crt. So enter the passphrase which you had given for ca.key. So then it will be you will be prompted to sign the certificate, and then yes again. So thus the certificate will be created. So when we check, you have a certificate.server.crt file generated, which is nothing but a certificate which is signed by the CA for this server. So here we can see that for this common name cns.com, the certificate authority has signed the certificate for this. So here we can see the public key info and the certificate which has been signed by the CA authority. This ends task 3. The certificate server.crt can be read in the readable format by using this command. So here we can see that the signature algorithm is SHA-1 with RSA encryption, and it also says that the certificate has been generated by this, that is asu.edu, the issuer. It shows the validity and it shows to whom the certificate has been created for. It shows the public key info, and then the signature algorithm. Task 4 is about securing a website using PKI and certificate. So what we do first is combine the security file and the certificate into one file, that is server.pem. So when we do this, it should be done. So we have something called server.pem here, which consists of the key followed by the certificate. So for convenience, make sure you have added the following entry into your etc host. Then launch a simple web server using this command. Enter the passphrase for server.pem. So this has been started. By default, the server will be listening on port 4433. Now when you check, it says the connection is untrusted because we haven't added the CA certificate, authority certificate, to our web browser. So how do we add the CA certificate to our web browser? Would be preference and then go to certificate, view certificate. Here we do an import and then go to the place where we have created a new certificate and then click open. Check on trusted CAs to identify websites. Okay, now check that the certificate has been added here. Now when we try to log into this again, we should be able to, we will not be seeing this and it will directly go to cns.com. Yeah, so it was not prompted to go to the connection is untrusted because we added the CA certificate. Now, if we try to log into localhost, we will not be able to. It will still show the connection is untrusted because the CA certificate would do a string comparison. So only cns.com will be recognized, and for all the other connections, it will be shown as untrusted. The same thing happens with 127.0.0.1 and also the IP address of the server, which is 192.168.3.2. So this shows that only cns.com will not take you to the untrusted domain. So by this we conclude that the CA certificate would do a string comparison and all the others like the IP address and the IP address of the server will not be recognized or authorized and is untrusted. The same task needs to be performed in Kali VM as well. For that, we need to copy the ca.crt from the Ubuntu machine to Kali. So we do an SCP to copy that. So the ca.certificate CRT has been copied. So, and also we need to write the IP address of Ubuntu machine with the server's common name to our host, etc host. Now when we try to ping, we will not be able to, when we try to access this cns.com, it says the connection is untrusted because the certificate has not been added. So now we can see that import in the certificate. So it's already authorized, so we can see that co.edu is here. So when we try to access it again, now since the certificate has been added, so we do not see the untrusted again. Now localhost has no meaning in this, so we cannot connect to it. And when we try the IP address of the server, it again says it's untrusted because what we have saved in the certificate is only cns.com. So by this, we successfully secured a website using certificate authority. And this ends our task 4. So the next task is a performance test for RSA and AES. OpenSSL speed is used to test and compare performance of different cipher algorithms. So in this task, we will be performing a speed test for AES and RSA. So by here we can see that here we can see the speed test for AES. Here it says doing AES 128 CBC for 3 seconds on 16 size blocks. So the output would be, so many bytes would be processed in 2.95 seconds. Similarly for RSA, doing doing 512-bit private RSAs for 10 seconds would give you so much 512-bit private key RSAs in 9.95 seconds. So this is mainly used to test and compare how different cipher algorithms would perform, and we can also use this for benchmarking of our test cases. This ends task 5. Thank you.